Okay, let's try a few more, and I'm going to zoom in to 274. Okay, so 274 has more than four terms. So let's break this down. So 112 divided by 2 is 56. Let's try 112 divided by 4 instead. So I have 4 and 28, and then I have 4 and 7. And notice how I did that so that I can actually group these two and bring that out. And here's my loner. So I actually have 4 square root of 7 plus 4 square root of 5 minus, since that 4 came out, I'd get negative 12 square root of 7. And then I'm going to continue with my last one. So this would be 4 times 8. This, I'm going to keep that alone. And this would be 4 times 2. So here's a group that comes out. This is my loner. So this would then be negative 16 square root of 2. Okay, so these two terms are the same. 4 minus 12 is negative 8 square root of 7 plus 4 square root of 5 minus 16 square root of 2. All of my square roots are different, and therefore I cannot do anything else. The most I could do is probably take out a 4, factor out a 4, and then I can have 2 square root of 7 minus square root of 5 plus 4 square root of 2. But you really don't need this one because it didn't say factor. The question actually just said to simplify. Okay, so you should be able to do the rest of these problems. You are distributing in 278. Just distribute. You're treating it like a variable, so this would be negative 2 square root of 50 minus 2 square root of 15, and then you could break that down, so 25 and 5. So let me do that on the side over here. So I have negative 2 square root of 50 minus 2 square root of 15. So I can't break that down. If I break this down, I get 25 and 2. 5 and 5. Here's my group. That comes out. He stays in. So this would be negative 10 square root of 2 minus 2 square root of 15. And I can't break down the square root of 15, so this would be ultimately my answer. All right, moving on. Solve each equation. Remember to check for extraneous solutions. So what that means is if I have an x over 1 minus x, in this case, my x cannot be 1 because x over 0 is undefined. So just make sure that if there was something on the denominator, that's what extraneous solutions is talking about. So we're going to do the opposite in order to get our x alone. So let's do the next couple problems. And I'm going to zoom in right here. So we'll do 284 first. So 1 equals square root of x. The opposite of square rooting is to square. So I'm going to square, so x equals 1. And that is my answer. My next one, 286. I have the square root of x minus 7 equals x minus 7. Remember, the opposite of square rooting is to square it. So this would just be x minus 7, and this would actually be FOILed. So x minus 7 times x minus 7, because you are squaring that whole thing. So you get x squared minus 14x plus 49, and then you get x minus 7. Now what you want to do is make sure you get 0 on one side. So I'm going to add 7 to both sides. And I get x squared minus 14x plus 56. And I'm actually going to subtract my x from both sides. Move this up so you can see. And I get 0 equals x squared minus 15x plus 56. So now we go back to factoring. So I need to factor this out. Two numbers that multiply to this invisible 1. So that's 1 and 1. Two numbers that multiply to 56. Let's try 8 and 7. They both need to be negative because I want to get a negative 15. So this would be x minus 7, or x minus 8, and then x minus 7 equals 0. And I'm not done, but I'm going to circle this. So what two options do I have? Well, x can equal 7 or x could equal 8. Let's do the last one. We could do this one. 287 looks a little bit more complicated. Okay, so I'm going to get rid of my plus 1, so I get square root of 5a plus 71 equals a plus 1. Again, the opposite of square rooting is squaring, so I'm going to square this whole thing. Remember, it's a plus 1 times a plus 1. When you FOIL, you actually get a squared plus 2a plus 1. And this would just disappear and make 5a plus 71. Let's put everything on the left side. So I would actually subtract a squared, subtract 2a, subtract 2a, and then subtract 1 and subtract 1. So on the bottom, I would have negative a squared plus 3a plus 70 equals 0. And we don't want a negative in front. So what I'm going to do is I'm going to take out that negative or factor it out, r squared, change the signs, equals 0. And then I'm going to factor my trinomial with my negative on the outside. So I know these two are going to be a's, and I need two numbers that multiply to 70. So maybe 7 and 10. So when I cross multiply here, I get 7. When I cross multiply here, I get 10. Which one has to be negative to get a negative 3? I believe the negative 10, negative 3, so this would be a positive. So a plus 7 and a minus 10. So now this would make it a equals negative 7 or a equals 10. And those are my two answers. All right, moving on. So keep, change, flip. So now you're going to have to combine your fraction knowledge with your factoring knowledge. So I'm going to do a few, and I'm going to zoom in over here. I'll do 4, why not? So 289, I have x plus 6 over 6x. I'm going to keep, I'm going to change, and I'm going to flip. So I get 5x cubed plus 30x squared. And automatically I notice that my denominator can be factored out. So I'm going to have x here plus 6, and then I'm going to keep the 4, and I'm going to copy everything down, 6x. So the good thing is that, oh my gosh, I have an x plus 6 and an x plus 6, and I can actually cancel those out. So now that I know that, on my top, my numerator, I have just 4. On my denominator, I have 30x cubed, and I am done. So this would be my answer for 289. Now, what I want you to realize is that this section is not just multiplying and dividing. So, yes, my 289 was division. I have a division problem here. I have a multiplication problem, right? But this section here is adding and subtracting. So you want the same denominator. So let me do 294 and 296. I'm going to zoom in and do that over here. So let's do 294. And I'll change my answer. So 294, the denominators are the same. So I can actually put them all under one fraction. So 25x cubed, then I have 3 minus, and you're distributing that to the x minus 4y. Don't forget, you are subtracting all of that, so you do want to distribute. So 3 minus x plus 4y over 25x cubed, and I can't do anything else, so this would be my answer. Okay, and then when I look at 296, I'll do it in green. So let's factor this denominator out because everything looks very complicated. So if I factor out a 4m and I get m, 2m, plus 3, then I know that my denominator is going to have a 4m, a 3, and a 2m plus 3. That's going to be my common denominator. So now whatever I do to the bottom, I do to the top. So let's just copy this down. 4m times 3 times 2m plus 3. Okay, and I'm adding. So let me erase this section. Oh, I can't. Okay. Let me erase right here. Okay, so just so that you can see a little bit what I'm doing. Okay, so whatever I do to the bottom, I have to do to the top. So in this case, and I'll use purple or orange, how did I go from 4m times 2m plus 3 to 4m times 3 times 2? In other words, what's missing? I believe my 3 is what I added. So whatever I do to the bottom, I do to the top. So if I multiply this by 3, I have to multiply my top by 3. And so my numerator is going to be 3 times 3m plus 4. And same thing goes for the 4/3. So the 4/3 looks like this was already here, but I actually added a 4m, and I actually added 2m plus 3. So I'm going to put that on the top because I multiplied this by a 4m and a 2m plus 3, and 2m plus 3 times 4m. So I get 4m times 4 times 2m plus 3. So now that they're the same denominator, I'm going to go ahead and put it all under 1. So equals 4m times 3 times 2m plus 3. And my first one would be 4m times 4 times 2m plus 3 plus, and I'm going to move this over, make this longer, plus 3 times 3m plus 4. Okay, so now I have 16m times 2m plus 3 plus 9m plus 12 all over 4m times 3 times 2m plus 3. And no, you can't cross cancel. You can't cross cancel because of these suckers right here. So unless they're all being multiplied, then no, you cannot cross cancel. So I'm going to distribute and get a 32m squared plus, what's 16 times 3? 48m plus 9m plus 12 over 4m times 3 times 2m plus 3. And I'll do parentheses instead. Okay. So now that I have this, let's change my color. Okay, so I'm going to combine the 48m and the 9m. So 48 plus 9 is 57. So 57m plus 12, I have 32m squared plus 57m plus 12 over 12m times 2m plus 3. And now I'm going to try to factor this out. I want to say that it's not divisible by 2, so let's see if 57 is divisible by 3. Yeah, so everything's divisible by 3, so let's go ahead and pull out a 3. So 32 divided by 3, actually 32 divided by 3 does not work. So in this case, I want to say, what about 7? No, 6, 4, 2. Well, let's try. Let's try and see if it's factorable. So 6, 8, and 4 make 32. and 6 and 2 make 12, so 4 times 6 is 24, and 8 times 2 is 16. Let's try that again the other way. So I have 48 and 8, and 48 plus 8 equals 56, but not 57. So this is actually my answer, and I am done. Okay, last section. Moving on to the last section of this packet. I want to make the same denominators, right? Some teachers will teach us that we need to make all three the same, but I'm going to teach you an easier way where just make the equation into two fractions, and that way you can cross multiply and go from there. So for example, let's take a look at number 299. So if I look at 299, I'm going to try to make the same denominator, so 7x squared and 7x squared. And I know that I multiplied this by an x. Oops, that's kind of confusing. So multiply this by x over x. So if I multiply that by x, then my top becomes an x. This stays the same, equals x minus 5 over x squared. So now that I have the same denominator on the left side, I can say x minus 1 all over 7x squared equals x minus 5 over x squared. And now, since I just have two fractions, I can cross multiply. And let me move this a little bit down. So I get x cubed minus x squared equals 7x cubed minus 35x squared. Now all my letters I need to make on the left side, so I'm going to subtract 7x cubed, subtract 7x cubed. From both sides I get negative 6x cubed minus x squared equals negative 35x squared. And then I'm going to add a 35x squared to both sides. So this becomes 0 equals, and I'm going to move this up. So I get negative 6x cubed minus 34 plus 34x squared. So now I can take out something. I know I can take out a negative 2. So I get 3x cubed. Actually, I could take more than that. So let's take out a x squared. And this would be 3x minus, because two negatives will be a positive. 34 divided by 2 is 17 equals 0. So now this is where you have to split and decide, okay, well, either this equals 0 or that equals 0. So negative 2x squared equals 0, or 3x minus 17 equals 0, and you just solve. So in this case, even if I divide by negative 2, x squared equals 0, so x equals 0. That's one answer. And then in my other one, I'm going to add 17, so I get 3x equals 17. And I want to know what x equals, so I'm going to divide both sides by 3. So x equals 17 over 3. If you really want to put it into a mixed number, you can do 3 goes into 17 5 times, which is 15. There's 2 left over. So this could also be your answer. But on a test, usually this answer should be fine. Thank you for watching. Hopefully this helped. The answers are, well, the answers to the packet that I'm showing in this video are in the next couple of slides. And the ones for your packet, if you need them, you can ask the sub for the answers. Okay, see you soon.